See, alkyl halides can be prepared from alkanes using the tertiary butoxy halide, also in the presence of sunlight. Let us see that. See, this is tertiary butoxy halide in the presence of sunlight. Of course, here we can take chlorine mostly, tertiary butoxy chloride. Okay. Now, in the presence of sunlight, this undergoes homolytic fission to form these free radicals. Okay. Now, this free radical with alkane forms okay. Now we get two free radicals this way. These two free radicals combine, okay, and you'll get alkyl free radical and of course tertiary butyl alcohol, right? Now this alkyl free radical with tertiary butoxy chloride again. Okay, you get free radicals here. Chlorine free radical combines with the alkyl free radical and you will get tertiary butoxy free radical. This again goes into the previous step. Okay, so this is how alkyl chlorides can be prepared from alkanes. Next, from alkenes as well as alkynes. The first one is hydrohalogenation or addition of hydrogen halide. Yes. See, in this case, let me give you two examples. Propene with HX gives isopropyl halide as the major product. N-propyl halide as the minor product. This is according to Markovnikov rule. Okay. And the mechanism that we follow here is electrophilic addition mechanism. See, it actually goes via a more stable carbocation. Okay. Very important. In fact, we have seen all these things in alkenes very clearly. Along with the mechanisms. So go through the mechanisms if you want to revise. Now the same thing if carried out in the presence of peroxide. Remember, peroxide effect is observed only with HBr. In this case, N-propyl halide is the major product and isopropyl halide is minor. So in this case, the mechanism followed is anti-Markovnikov or peroxide or Kharash effect. The mechanism followed is free radical addition reaction which goes via a more stable free radical. Okay. So these are very important. See the difference in the mechanism. Remember, it happens only with HBr. When it comes to alkynes, let me give you this example. With HX, the reaction occurs in two steps. We know that. Again, according to Markovnikov. On further reaction with another molecule of HX, we get this. Okay, next. Now, going for the addition of halogen. See, in case of alkenes with halogen in a solvent CCl4, we get this. So, this in fact is anti addition. Okay. Next. With alkynes, it is this way. We get tetrahaloalkanes. Okay. These are all, in fact, discussed ones. Coming to allylic halogenation. Let me give you the list of reagents used for allylic halogenation. We have reagents like NBS or NCS in the presence of sunlight. There is a sulfuryl chloride in the presence of sunlight or peroxide. Then, of course, chlorine at a high temperature. All these are meant for allylic halogenation. Okay. Let me give you one or two examples. When propene is treated with NBS in the presence of sunlight, let me just label this. So that is a radioisotope of carbon, let us suppose. You get this with the radioisotope at this position. See, it is because initially we get this free radical from this, and now this undergoes a rearrangement. Okay, so that can be shown. Because of this, you get two free radicals here. Now then, these two combine. Okay, so finally, we get this one. But still, the labeled carbon will be here only. Now look at the free radical. So that is how you get two different free radicals. Now when this free radical is considered, the product that we get is this. Okay. And now it is this. So this is interesting. Can be observed only by labeling the carbon. Next. Let me take one more example. See if this is considered. It's but-1-ene. With NBS, we get two different products. This one, known as kinetically controlled product. Right? Next. See, in the formation of this kinetically controlled product, you just consider this. The basic free radical with no rearrangement, it is formed. In fact, we call this kinetically controlled because it is faster formed. Okay. And remember, this is minor. It's of course less stable also. Now coming to something formed after rearrangement. Right. Now this is where it goes. And you get a bromine here. With the labeled carbon at the same position. Now this is what we call thermodynamically controlled product. Thermodynamically controlled is in fact more stable. Resonance stabilized one, and remember this is major. Okay. So in general, with NBS, in the presence of sunlight or UV light, the thermodynamically controlled one is a major product. Okay. Now some fresh preparations of alkyl halides. First of all, from alcohols. See, alcohols react with PCl5 or PCl3 or thionyl chloride in the presence of pyridine. Okay, so this is thionyl chloride. Then there is the same thionyl chloride but in the absence of pyridine, or you can use carbon tetrachloride. Okay, let me tell you that here the mechanisms are different. With the thionyl chloride in pyridine, the mechanism followed is SN2, and in this case the mechanism followed is SNI, nucleophilic substitution internal. Okay, now finally the product formed in all the different cases is alkyl chloride. Okay, now let us take the mechanism with PC alpha. Alcohol with PCl5. For convenience, let us consider it as this RCl, HCl, and the thing that is left out is POCl3. Phosphorus oxychloride. Okay, now the mechanism. PCl5 Now, as and when the lone pair attacks, this goes off. Minus Cl minus, and we get this. See, in the next step, the Cl minus abstracts the proton, and then this will go towards the positive charge. Okay. Now the interesting part. See, as and when this comes here, chloride attacks the alkyl group from the backside. This is what I call SN2 mechanism, which results in inversion. The backside attack is the characteristic of SN2 mechanism. Now see what all we get. Alkyl chloride, then of course POCl3. Here anyway we got HCl. Okay. Along with this HCl. So this is a mechanism. And the interesting part of this is with PCl5, the mechanism is SN2. With PCl3, phosphorus trichloride. Let us take 3 moles. We get 3 moles of alkyl chloride. Along with that, H3PO3, right? Nothing but phosphorus acid or orthophosphorus acid, a dibasic acid. And now the mechanism. just as in the previous case. As and when this comes, the chloride goes off. Cl minus goes off, and we get R, O, a hydrogen, positive charge, phosphorus, which has still got its pair of electron, then the two chlorines. Okay. Now, say this chloride straight away attacks the alkyl group from the back side. So here again it is SN2 mechanism with inversion of the configuration. We get alkyl chloride, along with that, see, chlorine, then of course the phosphorus with one OH group. Okay. Now this further reacts. I mean, we'll be repeating the same steps for two more times. This way, the same kind of things are repeated finally to get we get H3PO3. Then, of course, two more moles of alkyl halide. We have already got one here and now two here. So overall it is 3 moles. Okay. See here, I have an important point for you. PCl3 can be directly used but not PBr3 and Pi3. See, because these are unstable. They cannot be used directly. Then what has to be done? These are prepared in situ. In situ refers to internally. Of course, these are prepared indirectly by reacting phosphorus